Show that when we differentiate this expression, we can get an expression of this form where p is an integer to be found. So I'm going to let y be e to the 4x over 4. Take away x e to the 4x. Now the first term's okay, but the second term here is a product. So we'll have u is x, v is e to the 4x. So du dx is equal to 1, and dv dx is going to be e to the 4x multiplied by the differential of the inside function, because we're using the chain rule, so it's 4e to the 4x. So dy dx is going to be, well, if we differentiate e to the 4x, we get 4e to the 4x, as we just saw. That's over 4. And then take away, we've got this product, so v du dx, so that's e to the 4x, and plus u dv dx, which is 4x e to the 4x. So tidying up, this is just e to the 4x, then we've got take away e to the 4x, then we've got take away 4x e to the 4x, which gives us negative 4x e to the 4x, and that means that p is equal to negative 4. Okay, so now we're told that we want to find the value of this integral. So one thing that should be clear is that if we integrate, and we may as well do it from 0 to ln 2, negative 4x e to the 4x, then we must get the expression that we started with up here. And that's just because of the reverse nature of differentiation and integration. So we've got e to the 4x over 4, take away x e to the 4x, to be evaluated from 0 to ln 2. Okay, so we actually only want x e to the 4x, and we get that by dividing both sides of this by negative 4. So it's going to be negative a quarter of this expression here. Now, if I was just doing this in an exam, I'd have probably done more steps there, but I'm just stepping this through one step at a time. Okay, so let's put in the top limit. So that's e to the 4 ln 2 over 4. And then take away ln 2 e to the 4 ln 2. If we put 0 in, e to the 0 is 1, so we've got a quarter. And of course this term, because of the x here, would end up being 0. So we've got negative a quarter. Now think about this. So if the 4 goes inside here, that's 2 to the 4, so it's e to the ln 16. Because we know the exponential function and the natural log are inverse functions, that just ends up being 16. Divided by this 4 is 4. And so that's 4 take away 4 ln 2. And then we've got this take away a quarter out here. We want an exact value, so we're not diving for the calculator at this point. So we've got negative a quarter, and then you've got 4 take away a quarter. Well, 4 is 16 quarters, take away that, so that's 15 over 4. Take away 4 ln 2. And so that is going to give me negative 15 over 16 plus ln 2.